And the question is again related to the assignment, which we have answered. However, I want to make it clear since he was a bit confused on the way we have considered the option, which is a correct option. So in week 4, the question was a voltage regulator has no load output at 18 volts and a full load output of 17.8 volts at load current of 50 milliampere. Load regulation will be dash, which is you need to fill the correct answer. The answers was answer were 11.1% or 0.22% per milliampere. Now, why we have used or is either you can say 11.1%, or if you write down that it is 0.22% per milliampere, both ways the answer is correct. Also, when you check the answer, you may have received answer which is 1.12% and not 1.11%. So 1.12 and 1.11 both would be correct answer, and that's why we have considered option B as a correct answer, 1.11% or 0.022% per milliampere. That is a correct answer. None of the above is not a correct answer, since you can find out the answer in terms of percentage per milliampere. So none of the above is difficult to answer because that answer 0.022% per milliampere is a correct answer. Also 1.12 or 1.11% is a correct answer. Thus correct answer would be option B. However, if you have not understood how to calculate this, we'll be happy to help you through forum. You can again ask the question and we'll send you the solution of that how you have to solve this question. Okay, so and actually Rohit got an answer which is very close, which is 1.1236. We don't care about a lot of digits after in terms of decimal, but 1.12 or 1.11 would be correct answer, Rohit. And unfortunately, I think you have selected none of the above or something else, and that's why we had to score 0. Don't worry about something that we need to understand is assignment consists of very few marks or weightage to the overall course, and it is more like learning rather than learning after marks. So do understand that whatever you have asked, I really appreciate because you have gone through details. You have got a very answer which is very close to the correct answer. The final option that you may have selected would be none of the above, and that's why we had to give a 0. All right. So, but don't worry. I think your thought process is absolutely correct. Let me go to the next question by same student. In week 5, a 3-terminal monolithic IC regulator can be used as current regulator, and power switch, an adjustable output voltage regulator, an adjustable and a current regulator. This you may have seen the results, but you please see the explanation in the forum. If you are not satisfied with the explanation, do send me an email and I'll answer your question in detail. However, I have seen the explanation in the forum, which makes sense. It is very clearly explained why for LM140K we have to get that particular answer as the correct answer. Let me take another question from another student, I think, and that is by Dr. Guru Murthy Sambandhan. I think he is also present right in this Zoom meeting. It's a live meeting. So the question is, I would like to know the inside details of op-amp, like how many transistors or amplifiers, etc. are there. So for that, Dr. Gurumurthy, way to do structure is using something called analog VLSI or digital VLSI. Now, generally, we go for analog VLSI circuit where we learn how to design different transistors using transistor, different amplifiers, filters, oscillators, and whatever you require in a given electronic module. To use that, you generally use a circuit design software called Cadence. Once you use Cadence and you design your circuit, you need to tap it out to an industry, and the fabrication industry will fabricate a device for you and send it back to you, which is called chip. Once you look in the chip and all the electronics are working, then you need to package that and make an integrated circuit. Okay. So I think Guru Murthy is saying that sound audio is not available. I don't know why, but because I can.
No, sir, you are audible, sir, to us.
Yeah. Okay. Okay. So Guru Murthy, maybe you need to just see why it is not available. I'll just write down here. Okay, okay. So I think you can just communicate through YouTube, or you can just chat here. You can chat here. Ask me a question, Guru Murthy, if you have any. You cannot speak, but at least you can type it here. So do that. So where was I? I was on the understanding how many transistors and amplifiers. So again, there is no fixed value of how many transistor and amplifier. Generally, when we read the book, it said millions of transistors, right? But it depends on what kind of circuit you are integrating within an amplifier, within a integrated circuit. So what happens is, let us take an example. If it is if it's application specific indicator circuit, right, then we need to see that what kind of electronic module that we are designing, and based on that, the number of transistors would be we can say this is a number of transistors. Now let us take a different example. Suppose you have a sensor, and the sensor is resistive based sensor. Okay, and then when we apply, let's say sensor is a gas sensor, for example. So in the presence of gas, as you know, there will be change in resistance, right? So if it's oxidizing gas, resistance would increase. If it's a reducing gas, resistance would decrease. So the final output of the sensor is resistance, change in resistance. But for the end user, they don't care about resistance. We have to show them in terms of concentration of the gas that is present in a given environment. So how you will design an electronic module? You start with your sensor, either connect it in a potential divider circuit, or you use Wheatstone bridge circuit, right? Then you have to amplify it. So you use instrumentation amplifier. Then you have to process it. So you use analog to digital converter. Then you have a microcontroller, and then you finally have a display. So this first part, Wheatstone bridge circuit and the amplifier, along with filters, if you want to design a filter, that can be part of the integrator circuit. All right. When it comes to Great. When it comes to integrated, when it comes to the microcontroller, then it's a separate IC. So, it again depends on what if you're computing, you have millions and millions of transistors because you have to do multiple processes at the same time. So that's how the design is taken care of. As I told, software that most of the electronics are used. Once you design the circuit, you can tap it out it is very difficult to do everything by one group, and that's why there are many groups working in a industry like Intel, TI, Qualcomm, right, and so and so. So this is what I can answer your question, Guru Murthy, depending on what you have asked me right now. But if you have more questions, you please feel free to type it here in the chat box. Let me take another question by Ranjit Pyati, and I think he is here. So the question is, can you help me in describing industry support for this op-amp application course? I am a little bit not sure what you mean by industry support, but what I can say is that if you learn this course and further you learn based on this course, the design course, which is your analog VLSI design, then there are many companies that look for the analog VLSI designers. There are also digital VLSI companies. Some of the companies that I can tell which comes here in the institute are TI, Qualcomm, Intel, right, Samsung, then recently TSMC. So these are some of the companies that look for the people who have understanding about the circuit design along with the analog electronics, in which the op-amp is a fundamental part of it. So that is the answer to your first question. In terms of industry support, I think industry directly does not put funding on just op-amp, but they put funding on designing a chip which has a certain application, or using their integrated circuit for some application. That means that, let me give an example. Suppose they have designed a new IC circuit which can be used to process 10 times faster than the conventional circuit, and then they want me to use that IC for certain application. And if I show that using this IC the application becomes better, then indirectly the industry can sell that IC, right? Because they have a proof of utilizing this IC for that application which is faster than the conventional circuits. So one way of industry support is to get their component, and they will fund you for that particular project if you use their components, to show the advantage of using that components over the other competitors. That's one way of doing it. Second way is, if you come up with a new design which is directly relevant to the industry, then there is a second part of funding that you can get from the industry. There are other ways of getting it. There is a semiconductor research consortium here in Bangalore, and if you see those consortium, you will see that what kind of projects are floated, what is industry working on, and how you can use your understanding about analog electronics plus different subjects to come up with a proposal, right? So this is some of the way to connect to industry or to go to industry. Now, let me take the second question again by Ranjit. And I hope my audio is clear, right? Okay. So the second question is, to work as a PhD scholar under you, what requirements I should acquire? Now, I generally don't encourage students to ask this question in the forum, because in the live lectures or sessions, because I believe that these sessions are not meant for answering those questions related to you joining my lab or joining the institute. However, since you have asked the question and it is already there in front of me, I'll answer this question. So to work as PhD scholar, you need to, if you already have an undergrad degree, you need to clear GATE exam, and then depending on number of applicant in a given department, for example, in my department, the faculty meeting happens, we decide what should be the GATE cutoff score, and depending on the cutoff score, the students are called for the interview. After you clear the interview, there are 5 different groups in this department. One is power, one is semiconductor devices, one is communication network signal processing, another one is neuromorphic and healthcare technologies. So you can select one of the groups to get interviewed. If you do well, right, your name will be shortlisted, and depending on the student who scores maximum, the student will be given the first priority. So this is how it happens if you have undergrad degree. If you have master's degree, you don't have to give GATE, you can directly apply and you will be called for interview irrespective of whatever your master's degree score is. That means if you have postgraduate degree, you will be called for interview. Again, the process remains same. You will select one of the group in which you are interested to work later, right? Or work in the research area of that particular group. And again, the interview happens and you have to answer the questions. Do understand that in any of this group, math is a basic requirement where a person or student should know a good math. Because we use it for several things, whether you say AI, whether you say signal processing, whether you say image processing, and lot more, right? So it's very important to have, because we, even for experimental group like mine, we go from understanding the theory, go for modeling, go for some simulations, then fabrication, and then application. Can you hear me? Is it possible? Now can you hear me? Okay, sorry. So yeah, I think there is some problem with the connections. That's why you may be not able to hear it clearly. But if that is the case, please do send an text here in the chat box. Okay. So I just reiterate that the math is a basic requirement for all the students who are applying in this department, including my group and any other group. Since we use signal processing, image processing, AI, even for experimental groups, we use theory, it's modeling, simulation, fabrication, application. So a lot of places we require a very strong math along with other basic science. Also, we see the interest of a candidate, what kind of new research domain they want to work on, and so on and so. So, what requirements I should acquire? I just told that fundamentals should be very clear, right? It is not just what we ask is op-amp. I am sure that all of you have studied or are studying this kind of courses in your undergrad. What you want to know is what kind of new problem that you want to work on, right? How excited you are to work on, and how committed you are to work on. These all things can be judged during the interview process. Further the same, just extending, because I'm answering in part, the question is very long, so I'm just breaking into multiple parts. The next question by Ranjit is, as I'm working as an assistant professor in EC department since from 7 years, and before to my MTech I have 5 years of experience, 12 years, please do reply. Okay. Yeah, so yeah, that is a good thing. If you have a lot of experience, that means your fundamentals would be better than students who has less number of experience, right? Less number of years experience. But having said that, sometimes what happens is that when we are in a particular teaching area, right, we try to forget the other research areas. Sometimes goes in a favor, sometimes goes in the against the applicant, but we really don't judge the applicant based on the age or any other criteria. We see every applicant in the same way, right? And we keep our question answers almost the same for every student, irrespective of the background of the student, experienced, non-experienced, male, female. We don't make any difference. All students are equally welcome to go for their higher studies. We encourage everyone who are eligible and who want to do research to appear in the interview process. At the least, you will know how to defend the questions that are asked in a pressurized situation. All right. So that's a good thing if somebody is experienced, but it's not a requirement. So I think I have these questions with me on the through the questions that were already asked. But in case if you want to ask any further questions, please feel free to ask here. Again, if Rohit, since he is not here, since this is already recorded, so I would request Rohit that if he wants to further discuss, he can send an email to me, and I'll be very happy to either send a reply back to through email, or to meet him personally through Teams or any other medium. Okay, because I want all students participating in this course to be happy, one, and to be to understand the things that we are teaching, right, and accept it to the core of their heart. That means that you should learn these subjects without having that kind of confusion of 1 mark here, 1 mark there, but your doubts should be clear. So do send an email, and I will be very happy to reply to your email, Rohit. So since we have only 3 students, what I can see here, who have joined, but if you have any other questions, Guru Murthy or Ranjit, please type it in a text box and I'll try to answer your question. Please suggest resources for further studies regarding op-amps. Yeah, I think in the syllabus. Yeah, sure. In the syllabus, I have given the list of books that one can study, right? So please look into the syllabus. If you don't find, you send me an email or ask in a forum, and we'll give you the complete list of books. But I believe that you will find the list of materials or books through which you can learn further. If you, however, you don't find it, please do send an request in forum, and we will answer your question. Okay, another question is from Manjit Kumar. Why simulation is important? Is the model 100% authentic? Is there any difference between practical labs simulated results? Yes, there is definitely a difference. No model is 100% accurate, right? Why we do simulation, right? So before we do simulation, we do modeling. And when we say model is a theoretical model, mathematical model, after which we go for simulation. Why we go for simulation? For example, if you want to fabricate a force sensor, all right, fabrication of force sensor requires many processes, and at any given process, if a step is not correct, you have to start from zero. So start from the first step. So it is better that whatever you are looking at, for example, if you want to have force sensor which can work between 0 to 1 Newton, all right, and it should be linear. Now, what should be the diaphragm thickness? What should be the doping concentration of the boron if you are using piezoresistor? All these things, if you do a simulation using COMSOL, it will give you results that, okay, if you go for this much diffusion, for example, 10 to the power 19 per centimeter cube of boron into p-type polysilicon, into n-type polysilicon, that will give you a piezoresistor of XYZ value. When you apply 1 Newton of force, you are expecting a change of resistance of dash kilo ohm. For that, you have to have a diaphragm thickness of only 10 microns, or out of 500 microns, you do H 490 microns. All these things we will know from simulation. Now, simulation parameters are a strict parameters within a given domain, within a given environment, within a given ecosystem. That means that it is assumed that when we fabricate, there will be no error. When we dope, it will be exactly 10 to the power 19. The time will not change. The DRI process, the time is absolutely correct. When you go for experiment, these parameters may not be absolutely matching, right? And that's why the experimental results would be deviating from the simulation result, but it should not deviate too much. Otherwise, your experimental parameters are wrong, right? If your model or if your simulation is 100% correct according to your understanding, the experimental results that you will get is close to 85%, or if it is really good, to 90% in the given environment that we are working, academic fabrication laboratories. All right, that's what I'm talking about. So if you bring it to 90% of the simulation results, that means you have achieved a good fabrication or the experimental data. All right, so that is the way you need to look into, Manjit. And it is very important to do simulation before fabrication, because fabrication is really expensive, right? So you don't want to invest your 2-3 lakh rupees into a fabrication without understanding that what are the results from my simulation. Because what happens is, you theoretically you can assume that, okay, it is 10 micron will give me the maximum results. When you do the simulation, you will have something different. So simulation is little bit one step in between fabrication and your theory, right? So I really suggest or advise students working in the area of fabrication and fabricating certain circuit designs, right, or as well as the electronic modules which requires fabrication of the industry fabrication, like micro technology fabrication, which includes PVD, CVD. PVD stands for physical vapor deposition, chemical vapor deposition, DRI, deep reactive ion etching, wet etching, right? You have photolithography, like X-ray lithography, beam lithography, your direct etching, right? Direct writing, and then you have PECVD, which then you have the ALCD, you have the atomic layer chemical vapor deposition, then you have LPCVD, low pressure chemical vapor deposition. All these techniques, whenever we are going to use, or some of these techniques we are going to use, it is really advisable to go for the COMSOL simulation. This is one example I'm giving. There are many other simulation software, but COMSOL multiphysics is what we use in this lab, right? So that's my answer to your question, Manjit. Let me take another question from Rakesh Chandra. What's your opinion on AI taking the jobs in semiconductor industries? I have no opinion about AI taking any jobs in semiconductor industries because and this is not part of this again this particular course. However, out of your curiosity, if you have asked, then I think that AI would be part of many other industries, not just semiconductor industries, and AI would not take up the job or take jobs from people. It will help and facilitate people to work way smarter, right? To reduce the error, which is a manual error. That's what I believe in usage of AI. AI should be helping to create more jobs and to help and manufacture and to reduce the faults that we generally cannot find in manual way. So that is my opinion towards AI helping us rather than taking up jobs from a skilled worker. All right, the skills that you obtain, particularly semiconductor industry, if you really know the fabrication process that is used in semiconductor industry, you will see that everything is automated. We have to just program it. Now, when I say we, is a scientist over there, is an engineer over there. They just do programming. Everything is already in the robot mode, and everything is done in a given clean room, that is class 100, class 10, depending on what kind of ICs they are designing, or they are designing sensors and other things. So I really am not against AI. I feel that AI should be used for betterment of the and to improve the jobs, to improve the overall yield, and to reduce the faults that are there with the human error, right? So that is my opinion, Rakesh. So let's not worry about AI taking jobs. Let us make our skill sets better, because we are the one who works on AI, not AI who makes humans, right? So we should not worry about that right now. I'm very optimistic about all the technologies that comes through should be used for betterment of humans, not against them. But like I said, this kind of debate can go forever, because you think something, I would say something. Different people have different opinion, right? So it's more like a question that can be discussed in depth, in breadth, right? But given a little bit time that we have in this live session, right? I would stop here. And if there are any other questions, I will be very happy to answer those questions. Thanks, Rakesh. In fact, after this session, right, maybe by 2 or so, we will send you the list of materials in forum. All right, the list of books that you need to go through if you are interested in learning other things other than what is covered in this particular course, or to further understand or improve the knowledge. So around 2 o'clock, because there is one more lively session after this. So once I finish that one, I'll try to get you the things. Yeah, Ranjit. So I think this course is a fundamental course that will help you to go to next level. That means that now, if you want to take an analog VLSI course in our department also, which is my department, Department of Electronic System Engineering, which was earlier called CEDT at IISc. we ask MTech student in our department to go through this course or similar course, which is now taken by other faculty, so that this course becomes a fundamental for you to take a next course, which is analog VLSI design and circuit. So that's how you can think about this course. That once you know this, you have fundamentals about the electronics, electronic module, and several different circuits, and use those as a base to learn next course, which is analog VLSI. Not really, Manjit. Depending on what kind of simulation you are using. For example, if you use COMSOL multiphysics, as the name itself says, you should have a very strong physics background, right? Or to understand the equations that are used in this particular software. Now, if you really learn that one, it will be nice to know, because you should understand that exactly what simulations or what equations the simulator is taking to give you the results. And to understand those equations automatically, either you should have a very strong background, or you learn by understanding the equation, go through the details and learn it further. Because I think the equations is more important rather than what exactly the software is doing. I don't think you will know the details about the code that is running in the software. If that is possible, then everyone will make their own simulation software, right? So what you will know is the equations that are used, and from that equations you should focus on those equations and see how the equations and the terminology within that each equation is used to solve the particular equation. So can you hear me now, Manjit? Yeah. So I hope, Manjit, you were able to hear what I was stressing on is to understand equation rather than the code behind the simulator. Okay, so if there is no other question, we will stop it here. If there are any other questions, please feel free to type in the chat box. If there is nothing, I just will wish you all the best for the remaining part of the course, right? We try our best to answer most of the question. In fact, we have answered almost every question that is there in the forum. However, if you feel that we have missed any, right? Because again, human error, right? Then you please send that question once again and we will answer. I am 99% sure that we have answered all the questions that are asked in the forum. However, like I said, if you feel that we have missed, do ask again. Or if you have any other questions which you may not be able to ask in this live session, you can use the forum, right? You can use this beautiful NPTEL platform, right, to get your things clear. So yeah, great. Thanks, Manjit. So I think if there is no other question, I'll just stop the session here. Right? You don't have any question. Okay. Okay, so I wish you all the best for your remaining part of the course. Not only this course, but all the other courses that you are taking through this particular NPTEL platform. And also, if you are working as a student or you're working as a professional, right? I wish you all the best in both of your careers. Feel free to send an email if you have really urgent questions which are not answered in forum. In case if they are not answered, send an email to me. I'll reply back to the recording and leave the meeting. Take care. Bye for now.